Now my next question is match the following. Column 1, here your function is given, that is x into modulus x root modulus x, and then x plus greatest integer x, and then again modulus x minus 1 plus modulus x plus 1. And in column 2, continuous in minus 1 1, differentiable in minus 1 1, strictly increasing minus in minus 1 1, not differentiable at least at one point in minus 1 1. So ultimately you see that to solve such type of problem, your knowledge of graph is very necessary, and graphically it becomes very easy to solve for you. So first of all, we know that, let me start one by one. For this, you know that modulus x, it is function modulus x, it is defined as x for x greater than equal to 0 and minus x for x less than 0. You all know this. So if you take the positive value, your function will become like this: x square, x into x square for x greater than equal to 0, and it will be minus x square for x less than 0. So your function will be this one. So now here it becomes very easy to draw the graph, because x square, you know that it is a parabola and it passes through the origin. So your graph will be somewhat like this. You see, your graph will be somewhat like this. This is x square and this is, your graph will be somewhat parabola, somewhat like this. Your graph will be somewhat like this. And now 1 and minus 1, you see that 1 and minus 1, you see that in this there is no break in this graph, so it is continuous. So this is continuous in open interval minus 1 1, continuous. Now let me check its differentiability. So this is the testing point here. This is your testing point. So let me test its differentiability. So your right hand derivative, that is your f dash x, that is limit h tends to 0 plus your fx plus h minus fx by h. This is your right hand derivative. So your zero is the testing point, because at 0 the graph changes. Why 0 is your testing point? Because at 0 your graph changes. Greater than 0 it is x square, and less than 0 it is minus x square. So at this point, so it graph changes. So I have taken the testing point as 0, and let us see its differentiability. So here it will become like this. So right hand derivative, that is for your x greater than 0, that is x greater than equal to 0, that is your right hand derivative. So this will be your function. So this comes out to be x plus h the whole square minus your x square, that is limit h tends to 0 by h. Now you place the value, this will be x square plus 2xh plus h square minus x square by h, and here your limit h tends to 0 here. So now this x square cancel out, you take h common here, so h cancels out, your x square and x square, this cancels out, this and this cancels out, and in the next step, if you take h common here, say limit h tends to 0, that means h common here 2x plus h by h, so h's cancel out, and now if h is 0, you remove the limit, it comes out to be twice x. So it comes out to be twice x. Again, your left hand derivative, if you go for left hand derivative, your left hand derivative will be somewhat like this, that is limit your h tends to 0 minus, I have made a shortcut here, because in left hand derivative, that is less than 0, your function will be this. So this comes out to be x, this is plus, for this will be x minus h the whole square minus f sorry, this will be x square minus x square, because your function is this, and divided by minus h. So here when you solve it, you will get same 2x. So you find that it is if you solve this, it same manner, it will be in the same manner. If you solve it, you are going to get 2x. So your left hand derivative is equal to right hand derivative. That means it is differentiable at x is equal to 0. It is differentiable at x is equal to 0. But since it is not given here, it has been not asked about to test the differentiability at x is equal to 0 in this question. It is not given to test the differentiability of x at x is equal to 0, but I have done this for you because it has only asked about the continuity. So it is continuous at minus 1 and 1. So it is continuous at minus 1 and 1, and it is differentiable at x is equal to 0. This is, I have shown it for you. Now for the next, that is second, for your second, what do you find in the second? So here now again, y is equal to root modulus x, y is equal to root modulus x. So here you see that whatever will be the value of x, whatever will be the value of x, you see that value of x, it will be y will be positive, but this root, because of this power root, what happens, that is your x increases, but y also increase, but there is but it also increase, but it increases very slowly. See, what is the conclusion you draw from this function? That is, you know that the modulus x, whatever be the value of x, either it is minus or positive or plus, the answer will be positive here. But what happens, this root, because of this root, y will increase, but it will increase, but it will increase very slowly. It will increase because slowly. You can say if you take x is equal to 4, then your y will be 2. If you take x is equal to, if you take x is equal to 9, your y will be 3. So you see here your x increases, but you see that your y slowly it decreases. You see that. Because what, because it is because of this root, function, your x increases. You take x is equal to 16, your y will be how much? 2. See here, y will be 16, 16. If you take x 9, your y will be 3 square, 3. If you take 4, your y will be, so your y will be 2, and then if you take 16, your y will be 4. So here you see, what do you see here from this conclusion? What do you see here? No doubt your y increases, but it increases very slowly in comparison to the x. It increases, but increases very slowly in comparison to the x. So your graph will be somewhat like this. It will increase, but it will increase slowly. It will increase, but it will increase slowly. Somewhat like this. You can see the graph will be somewhat like this. X O x dash, y O y dash. You see here. Such type of assessment you have to do it yourself. That is, this type of rough assessment you have to do it yourself, that what will be the shape of this graph. Again I am telling you that because of this modulus x, that is whatever be the value of x, that means either it is positive or negative, it will be positive, but because of this root function, your y will increase, but it will increase very slowly. See here, that means in comparison to x, the increase in y is very slow. That is, in comparison to x, your increase in y will be very slow. So the graph will be almost like this. So here you see that the graph, it is continuous. it is continuous in the open interval, it is continuous in the open interval -1 to 1, but it is not differentiable at x is equal to 0, because here you see the slope changes. The slope changes at x is equal to 0, your slope changes. Here your slope changes. So here it is in the first quadrant and here it is in the second quadrant. So your the value of the slope changes at x is equal to 0. So remember something, you have to remember, for modulus x, it is not differentiable at x is equal to 0. At x is equal to 0, it is not differentiable. You must keep in mind that for modulus x function, it is not differentiable at x is equal to 0, but no doubt it is continuous at x is equal to 0, but it is not differentiable at x is equal to 0. So such type of conclusions you must remember. So here you see that, one thing here you see that, since here your slope changes, so it is not differentiable at x is equal to, but it is continuous in the open interval -1 to 1. So this is, it is continuous, it is continuous in your open interval -1 to 1, but it is not differentiable, it is not differentiable, it is not differentiable at x is equal to 0. At x it is not differentiable, because why? Because here your the slope changes. So this is in the first quadrant and this slope comes in the second quadrant. So your this is positive but this is negative, so here it is not differentiable at x is equal to 0. Now I am moving to this third, this is complete. Now I am moving to this third part. So in this third part, let me see what happens. Your function is y is equal to x plus greatest integer function. But in this question, as it is, I have already told you that the limit is in the open interval -1 to 1. Everywhere your limit is in between -1 to 1. So, but here this is a greatest integer function. Two things it is given to you, your limit it has been given between -1 to 1. But at the same time, here greatest integer function is given to you. So I will divide it into again into two different intervals, that is x greater than equal to -1 less than 0, and another will be x greater than 0 and less than, greater than equal to 0 and less than 1. So here you see, because of this greatest integer function, I have to break this interval into two parts. I have to break this interval into two parts. Now see here, in your question it is in the open interval, everywhere it is open interval. But here again there is a greatest integer function. So because of this greatest integer function, I am bound to make this into two interval, and as you know, this open interval, this means that x is greater than -1 less than 1, but here it comes x is greater than equal to -1. So now what happens, because of this greatest integer function, I am bound to take this as equal to greater than equal to -1, because there is no other way. It may be given in this question, but as this is the greatest integer function, because this is the greatest integer function, so I am bound to break this interval into two parts, and at the same time this you have to include this -1, because there is no other way. So from this you are going to get two types of graph. One is for this, your y will be equal to x -1 for this, and for this your y will be equal to x plus 1. So for this, in this interval it will be y is equal to x minus 1, and for this interval it will be this. I am telling to you that no doubt in this question, it is given in the open interval. So Here you see that it is given in the open interval, but as here it is given greatest integer function, so I have to break this, I am bound to break this in two intervals, and at the same time you see here that I have to take this equal to -1 because of this greatest integer, because there is no other way possible, and whatever may be the question, I have to do some type of manipulation here because of this greatest integer function, and from this I am going to get two values, that is this. That means your y is equal to x minus 1 for x greater than equal to -1 and less than 0, and another that is x plus 1, that is for x greater than equal to 0 and less than 1. 1 minute greater than 1 minute, 1 minute, 1 minute, 1 minute, 1 minute, this will be 0, and here for this will be I have made a mistake here. 1 minute, I have made a mistake here. See, I have made a mistake here. That is, I made a mistake here. That is here. For x greater than equal to -1 and less than 0, and another will be x greater than equal to 0 less than 1. So here less than 1. X greater than equal to -2 less than -1, and another x greater than equal to this is not possible. Earlier it was correct. 1 minute. Again I am telling you here that because of this greatest integer function, I have to break this interval into two parts, that is x greater than equal to -1 less than 0, x greater than equal to less than 1. So for here this your y value will be 0, and for here your y value will be for this your y value will be -1, sorry, and for this your y value will be 0. For this your y value will be -1, and for this your y will be 0. So that means here in this interval you are going to get y is equal to x minus 1, and here in this interval you are going to get y is equal to x. You are going to get y is equal to x. Again I am repeating it for you that there may be a confusion among you, because in this question everywhere it is in the open interval -1 to 1. So why I have taken here as a closed interval, that is here -1. So you see that because of this greatest integer function, I am bound to divide this interval into two parts, and at the same time because of this greatest integer function, I am bound to take this as equal to x greater than equal to -1 less than 0 and x greater than equal to 0 less than 1, because there is no other way, because the greatest integer function itself it defines that it should be like this. So there is no other way for me, so I am bound to solve it in this very way. So here you are getting, for this your function is this, and for this your function is this. Now if you draw this graph, how will be the shape of this graph? If you draw this graph, what will be the shape of this graph? See here, what will be the shape of this graph? X, O, X dash, what will be the shape of this graph? Now you see here. What will be the shape of this graph? So when x is equal to 0, for the y is -1, yes, somewhere x is equal to, it is -1, and x is -1, And after that, for within this interval, if you go within this interval, x value within this interval, that is here, it is -1, x -1. So within this interval, uh, you are going to get this negative values. So here you see that if you take -1, if you take -1, your this will be somewhere like here like this. Here like this, that is -2. It will be somewhere here like this. So as this from -1 to this, if you take say -0.5, that means it will be minus 1.5. So your graph 1.5 somewhere like this, 0.5, it will be somewhere like this. So your graph will be somewhat like this, straight line, somewhat like this. Now see, again I am going to tell you one thing. See, I am going to again tell you one thing. Again, this is a very important part, and why I have taken some time to explain you, because this is a very important part. Again, I am going to repeat it, that as you know, it is given in this open interval -1 and 1. At the same time, your function is greatest integer function. So I am bound to divide this into two parts, and at the same time, because it is greatest integer function, so this will be included -1, x greater than equal to -1 less than 0, and this for this two for this there are two sets of x value, and for this x value your y will be 1, and for this value your y will be 0, because you see here that is y is equal to x. For this your y will be -1, so x -1, so this will be your function. And for this y is equal to x, for this in this it will be y equal to 0, so this is plus 0. So you are getting two types of graph. Now let me draw this graph. Your graph will be somewhat like this. You draw this graph. Your graph will be somewhat like this. See here. For if you draw this graph, for x is equal to 0, it will be somewhere -1 here. And if you take x is equal to -1, it will be say somewhere here, if you take -1, your point will be somewhere here. And similarly, if you take 0.5, that means -1.5, this is -2, and -1.5, this will be -1.5, and this is say 0.5 minus 0.5. So your point will be somewhere like this. See, and x is equal to 0, it is -1. The most interesting point here is that, you see again a most interesting point, since your x is not equal to 0, that means you can't touch the value of -1, you can't touch the value of -1. So instead of circle, let me do the point, because then otherwise it will create a confusion to you. This is your point and this is your point, this is your point. So here you see that since your x is not equal to 0, so you can't get the value of x, since x is not equal, you can get the value of -1, but you will be nearest to -1. So your graph is somewhat like this. You can't get -1, so your graph is this, a straight line. You touch the circumference of this, and this your graph is this. So now you see that you have got this, it has not touched -1. So here you see it has not touched -1. You can easily see that it has not touched -1. Again, for this part you see that 0 it is 0, and for 1 for 1 here it is 1, your for 1 it is 1, so your point will be somewhere like this here. So again you see that because you can't touch 1, so you can't get the value y is equal to 1. You can't get the value y is equal to 1, but it will be nearest to the 1, so your graph is like this. See the interesting point of this question, again I want to tell you this is a very interesting question, and again I want to tell you that in this question it is given here, you see everywhere it is given, it is open interval -1 to 1. But at the same time here it is the function, it is given to you x plus this greatest integer function. So because of this greatest integer function, I am bound to divide it into two parts. So x greater than equal to -1 and less than 0, and x greater than equal to 0 and less than 1. So there may be a confusion among you because there is open here, so how can we take -1? But I am again telling you, because of this greatest integer function, I am bound to take this as -1. But everything will be clarified when we draw the graph. So for in this interval your y value is -1, so your function will be equal to y is equal to x minus 1. Let me take this at fx, your function will this, and for this interval your y will be equal to 0 and your function will be, this function will be, this is your function, this will be become is equal to x. So now if you draw this graph within this interval, you see, for if let me take 0, it will be -1, for -1 it will be -2, -0.5, 1.5. So here again you see that because it is not equal to 0, so you can't get the value of -1, because it is not equal to 0, so you can't get the value of -1, so it will be nearest to the -1, so I have made a circle and I have touched only the circumference because you can't touch 1. Again for this you see that in this interval you can touch 0 for 1, if you take 1 y will be 1 no doubt, but since it is not equal to 1, so you can't touch 1, so your graph will be this. So ultimately you see it has become between, the graph is between -1 and 1, open interval between minus and 1, it has satisfied the given condition which is given in the question. So see, this is the interesting point of this question. By the help of the graph I got this condition is satisfied, and this is your graph. So in this interval -1, so here you see there is a break, the graph, there is a break, there is a graph, no doubt the graph is break at x is equal to 0. So in this interval, in this -1 to 1, it is not continuous, so I can conclude that it is not continuous, not continuous in open interval -1 to 1. So you can see it is not continuous in the open interval -1 to 1, and at the same time it is not differentiable because there is a steep change at x is equal to 0. So you can see that it is not differentiable at 0. It is not differentiable at x is equal to 0. It is clear here because since it is not continuous at x is equal to 0, so in the open interval, this is the open interval, it is not continuous because at x is equal to 0, it is clear here from this graph there is a break here, so there is a break here. So from this graph you see that there is a break here, there is a break here in this graph, so it is not continuous, and at the same time it is not differentiable, at x is equal to 0. It is not differentiable at x is equal to 0. So see, what is the interesting point of this question is that, again this is very interesting. You have taken here close interval, but the graph has helped you to that your graph becomes open interval between -1 to 1. So it is not continuous because there is a break here. See, this graph has break at x is equal to 0, so it is not continuous, and at the same time it is not differentiable at x is equal to 0. So in this interval there is a break, so it is not continuous, and this is the most important point, and this is how this graph has clarified you, and so it is very interesting. That means now you have seen that it's very, you have seen everything. It is not continuous means in this interval it is not continuous in open interval. That means actually it is not continuous it is not continuous, actually it is not continuous, not continuous, it is not continuous, it is not continuous, uh, OUS not continuous at x is equal to 0. Means in this interval, this graph in this interval there is a break. I want to say that in this interval there is a break. Where is the break? It is the break at x is equal to 0. It is the break at x is equal to 0. That means it is in most specified form it is not continuous, because everywhere it is given in the interval open interval -1 to 0. So the graph in this open interval there is a break. This graph is not continuous in this open interval. There is a break where at x is equal to 0. There is a break. That means it is not continuous at x is equal to 0. Now my last section, that is this one. Y is equal to x minus 1 plus x plus 1. So here you see that one thing, you know the definition of x minus 1. So this is x minus 1 for x minus 1 greater than equal to 0. That means x is greater than equal to 1. And another value is minus x minus 1 for x minus 1 less than 0. That is x less than 1. Similarly for your x plus 1, here you see it is x plus 1 for x plus 1 greater than equal to 0, that means x greater than equal to minus 1, and minus x plus 1 for x plus 1 less than 0, that is x less than minus 1. So here you see this minus 1 and another is plus 1. So within this again I am going to break an interval, that is break into two parts, that is 0. So your first will be x less than minus 1. So for less than minus 1, here you see less than minus 1 means this side less than minus 1. So less than minus 1 this side, less than minus 1 this will be, this is this, and your this one, because here this also it moves in the direction of minus 1. So your y will be equal to minus x minus 1 and then again minus x plus 1. So y will be equal to minus x plus 1 minus x minus 1. So y will be equal to 2x. Now again in this interval you see x greater than equal to minus 1 less than 0 in this interval, that is greater than minus 1 greater than minus 1 greater than minus 1, that is minus 1, this will be your, this is your greater than minus 1, and another is less than this less than 0. Less than 0 means this one, less than minus 1 means less than 1 means this is moving in the direction towards this minus 1. So here this will be how much, y equal to minus x minus 1, and for and this greater than this one, greater than minus 1, this will be this one. So this will be x plus 1. So this comes out to be minus x plus 1 and x plus 1. So this is equal to 2x. So y is equal to 2x for this. And another that will between this is x greater than 0 and greater than equal to 0 and less than 1. So greater than 0, that means greater than 0, greater than this portion, this is this portion here you see, this is greater than 0 because less than 1, but it is greater than this portion. So this will be y is equal to this is your in this region uh, uh, greater than 0, greater than 0 and less than 1. Now okay, greater, this one is this portion, that is minus x minus 1 and less than 1. This is less than 1, you can say less than 1 and greater than minus 1. See, less than 1, less than 1, this is your function, and greater than 0, that means greater than 0 this one, because this one is moving towards this direction. So in this direction, these are in this direction, it is covering this area, so this will be uh, plus x plus 1, so y is equal to, it will be 2x, as y will be 2, y will be 2, and again here you see for x greater than equal to 1, greater than 1, your this will be this function, y is equal to, y will be equal to x minus 1 greater than 1, and this one is also moving in the same direction, greater than minus 1, this is also moving in the same direction, so this will be x plus 1, so y will be equal to 2x. So these are the condition. According to this condition, I have got this result. I have got this result. See, again I am repeating this. So here we have got two points, that is minus 1 and 0, but I am going to take another point 0, that means I am going to divide it into two parts. In this between minus and 1, I am going to divide it into two parts. So here you see that two parts. So x less than minus 1, so less than minus 1, for this less than minus 1, less than minus 1, this will be less than minus 1, this graph is moving in less than minus 1 direction, so for this will be this one, and for this less than minus 1, it is this one, so when we place it we get 2x. Now in this interval x greater than minus 1, x greater than minus 1, that means x greater than minus 1, for this will be this one, because this region comes under here, less than minus 1, because this region comes under here, so this will be this one, and less than 0, greater than minus 1, and less than 0, for less than 0, this will be your less than 0, this region, this graph will be in this region, less than 0, this will come in this region, it will occupy this region, so here this is plus and you get 2x, and again oh sorry, not 2x, 2, sorry, 2, I am getting 2, and again x greater than equal to 0, less than 1, in this region, greater than 0, for this greater than 0, this will be this region will come under this greater than 0, when less than 1, that will this will have this region, this less than minus 1 will have this region, so I have taken for this one is minus, and less than 1, that means this region will have this greater than minus 1 will include this region, so I have taken this, so here you see this one, and you get result 2, and for x greater than 1, that is greater than 1, this will be this region, and for greater than 1, this is minus 1, this when you get is greater than minus 1, this will include this region, so it is x plus 1, I get 2x. Now if we draw this graph, what we get? If we draw this graph, x o x dash and y y dash. If you draw this graph, what are you going to get? That is in this region less than -1 and 1. In this region, for -1 it will be this is 1 and this is 2. For -1 this will be sorry, this is -2x. Again something is missing here, that is equal to -2x. So for in this region less than -1, in this region it will be if you take -1 it will be 2, and then for 2, and then for less minus it will be minus +4. So your graph will move like this, something like this. Graph will move like this. And for in this region it is 2, so in this region it -1 it will touch -1, and here less than 0 it will, in this region it will be it will be 2, and again 0 to 1 in this region, again in this region it will be 2, here 2, and for greater than 1 it will be again this. So here you see that your graph will be something like this. This graph is y equal to -2x, and this graph is y is equal to 2x. So here you see you get this graph. So in the open interval here, this -1 and -1, in this open interval it is continuous. Your graph is continuous. In this open interval -1 to 1, and it is also differentiable. It is also differentiable in this open interval. It is also differentiable in this open interval -1 to 1. You will get this. It is also differentiable in the open interval -1 to 1. So here you see that. So this is the graph. Again, I am going to tell you. I am again going to explain you. Here you see how to draw this graph. You know that this is, I think so, this is the definition according to the definition of modulus, and this is also according to definition of modulus. Now your interval, it is between -1 and 1. So I have taken another interval, that is I have taken another point in between, is 0, and I have divided into 4 different parts. So it becomes easy to draw this graph, because greater than 1 and greater than -1, this portion remains as a blank. So I have to occupy this region also. So how this is done, you see here. For first of all, let us say x less than -1, there is case less than -1. For less than -1, here you see, for this is your graph. So less than -1, this one, because less than 1, here is less than 1, this region, and less than -1 for this less than -1, this is -1, so less than -1, this region. So here you see this region also includes this region. So for this region less than -1 also includes this region. So here less than -1, this for less than 1, for this, because this graph also includes this region. So I have taken this, this will follow this graph, and less than -1 it will follow this graph. So you get -2x. Again in this region -1 to 0, here in this region -1 to 0, greater than -1. So greater than -1, here this region, this graph will include this region. This graph you can see less than 1, this graph will include this region. So this is minus, and again less than 0, that means this is greater than this -1, this one graph. So this graph you see it will include this region, greater than -1, it will include this region. Here you see it will include this region. So for this I have taken greater than -1, greater than -1, so this is this region, it will include this region, this C less than minus 1, less than 1, this will include this reason, it will include this reason. And so I have, for this reason, I have taken greater than minus 1, I have taken this as this one, this. And again, for this graph, it is C, it is less than 1, it is for this graph, for this graph, it is greater than minus 1, this graph. So see here, this graph, it includes this reason. So I have taken this one, so it is 2. Similarly, for x greater than equal to 0 less than 1, greater than equal to 0 less than, in this reason, here you see for this greater than 0, that means greater than this reason, this graph will include this reason. So I have taken here C minus. And less than 1, for less than 1, greater than 0, greater than 0, this one. And for this less than 1, that means this one, this reason, greater than minus 1, this reason will include this reason. So I have taken here this plus, it comes out to be 2. And for x greater than 1, that is this one will this. And this, you see this one, this reason also includes this reason greater than 1. So I have taken here plus this reason, see, it includes this reason greater than minus 1. So I have taken this as this, so I get 2x. And if we draw this graph, from this graph you get this here, such type of graph. Here you say, for if you take, you can't take minus 1, but I have taken minus 1, so it will be 2x. It won't touch 2x, it won't touch this 2, but again you see, when we take this one, if we touch 1, then it will be 2 here. So again for this again here also the same thing, it won't touch 1, but here it will touch 1. So ultimately your graph becomes like this, this is your graph. So in this open interval, you can, if you, as the question it is mentioned, open interval, in this open interval you see this graph is continuous and it is also differentiable in this open interval. So here it is also differentiable in the open interval, minus 1 to 1, it is differentiable. Or you can test here this at minus 1, you can also test here, or you can test in one, that is left hand derivative and right hand derivative, you can test here you can test here. But from this graph it is clear that in this region, in this region, one thing is there, it is there is one thing, it is no doubt it is continuous. Here you see it is continuous in this region, but no doubt it is continuous in this interval. It is continuous in this interval, minus 1 to 1, it is continuous in this interval. But here beyond this it is strictly increasing. Here this graph is strictly, no, this is not, beyond this it is strictly increasing, but here there is, it is not strictly increasing. Now the point here arises that differentiability between this open interval, your graph is a straight line, so your graph is a straight line constant, so this is a constant, so your derivative will be 0, so your derivative will be 0, and your, since your derivative is 0, your derivative is 0, that means there is no point of differentiability. There is no point, means here this is a constant, this is here in this region your graph is constant in this open interval. Here you see in this open interval minus 1 to 1, your graph is y is equal to 2. So y is equal to 2, if you differentiate it, this is a constant, so when you differentiate it, dy by dx is equal to 0. That means dy by dx is 0. You do not have any uh, uh, mm, uh, that means tan theta is 0. Tan theta is 0, that means the graph is parallel to x-axis. Graph is parallel to x-axis. So parallel to x-axis. It is parallel to x-axis, it is clear. So you can say that it is differentiable. It is differentiable. It is differentiable in the open interval -1 to 1. You can say that it is differentiable in the open interval -1 to 1. So I think so. You have understood it. So such type of queries, such type of complications, such type of mm, uh, decision makings occur. So it is up to you how you decide it, because if in this simple case, because in this open interval here, this graph in this open interval, it is a straight line which is parallel to x-axis. So there is no break in this open interval, so it is continuous. And since in this interval it is continuous, so in this interval it is also differentiable, because your dy by dx is your slope is parallel to x-axis at every point. At every point here it is parallel to x-axis, so your yeah, so it is differentiable in this point, in this open interval differentiable. So this is all about this question. I have only tried to explain you how to draw this graph in this question. I have only tried to tell you how to draw this graph and how to determine how the graph help you. First of all, the most important point I want to tell you in this question is that how to draw the graph of each functions, how to draw this graph. And at the same time, I have to take some decisions. In this case, I have to take some decisions. We have to take a point 0, and I have divided this into 4 sections, so that it becomes easy to draw the graph. If you take only these 2 sections, then only this and this graph will be available to you. But as per this question, in the open interval -1 to 1, there is, you are going to get no graph. So I have to divide it into, I have to take a point 0, so that it could be able to make it into 4 sections. And while making this 4 section, I am able to draw this graph. So I have got this graph. And because our here is our concentration is between the open interval -1 to 1, so it is clear that it is continuous in the open interval -1 to 1, and it is differentiable in the open interval -1 to 1. So in this question, I have selected this question because why? I want to show you the most important point here, that how by the help of graph you can determine the continuity and differentiability in a given interval. And at the same time, I want to to show you that the importance of this graph, how this graph helps you to find the continuity as well as differentiability, and how to draw this. The most important point is how to draw this graph, how to draw such type of graph. So I have only selected this problem only to concentrate on you, that how to draw this graph and how you have to take some decisions. You have to take in this, you have to take in this also, you are bound to take some decisions, so that you can be able to draw this graph. And that decision will help you to bring the whole graph in the interval -1 to 1. And so I have selected it. The most important point, the point I want to stress you, this is that how to draw this graph and how to take some decisions, so that you can be able to draw this graph. At the same time, how this graph helps you to find the continuity as well as differentiability. This is the most important. So I have selected this problem. So so you have seen that you have to be very in drawing this graph or selecting, you have to have some experience. That means you have to deal with many such type of different types of problems, which will help you to make decisions.